Okay, hello everyone. I guess today we only have a couple of minutes, but let me quickly check if any of you has any questions before we start. As showing we need to modify our lab, can we just do get poll? Okay, so quick 2 questions about the labs. So the first one is, how do we do test cases for lab 1, question 1 and 5? I believe question 1 and 5 are the ones that are not taking any input, if I remember correctly. As we said last lecture and in the tutorial, if the question is taking no input, in fact, you only need a single test case, because whatever value you provide in the test case will not reflect in your question. And you are already given test cases for this. So for the questions that take no input, you just simply don't write any additional test case. You can if you want, but it wouldn't really affect anything. So generally, if there is no input, don't write test cases for this. I know that the lab stated you need to write at least a single test case for each question, which you can still do for question 1 and 5, or generally for questions that take no input, but they will show no effect. So it's up to you, in fact. With regard to the modification of the lab, this was the second question. I believe the best way of doing this is as like the announcement details. I don't want to go through these details here in the lecture. If anyone has a problem after doing what I suggested, we can check in the office hours. But we tested what I sent you multiple times under different conditions, and it seems to be the easiest way. I was looking for the easiest way. I guess the question is saying, can I just simply do a git poll? You can try, but in fact, generally it should work. But one of the problems we face is when you try to do a git poll, based on what you change it locally, you might need to do a merge. And I didn't want you guys to get involved in conflicts and merges and what to do. So I said maybe it's simply just to do what I suggested. Good. Any other related lab questions, please come to the office hours, and we can, because this is the easiest way for us and for you to check the specifics of the problem you have. So please come to the office hours, and we can look this. Okay, so it's 31. So let's start, and hopefully I can take questions every 10 minutes as I do. So last time we stopped here, and what we were doing, let's recall what we were doing. So after going through some of the examples and doing some practical programming together, and after finishing lab 0, we kind of took a pause and said, let's now consolidate a little bit our knowledge. So what really we are doing, what is the general, what are the general rules of the different programmings we are doing, like how loops generally work in C, conditions, different possible conditions, data types, and this was the purpose of last lecture and today's lecture as well. With regard to slides, you are going to continue the slides from last lecture, so there are no new slides for this lecture. You can already use the ones from previous lecture. Okay, so we stopped at this slide, if I remember correctly. We were discussing for loops and different possibilities or alternatives of writing a for loop. So looking into these 3 for loops, for example, the first one, maybe I prefer to use my pen. Oh, what did I do? Okay, good. So the first one here is it's like the traditional one. This is the one that you will see in most of the cases. You start from 0 and you have less than a certain count. And last time we discussed what is I++, which means you increase I after you execute your iteration. So starting from 0 less than 20, that means it's 0 to 19. So that means you're going basically to print a star 20 times, right? This is one way of doing it. But you can have as many alternatives as you wish, in fact. So you can start from 1, and instead of just less than 20, you do less than or equal. And that means now you will start 1, 2, 3, 4, up to 20. So 1 to 20. Previously, start from 0 to 19. 0 to 19, 1 to 20, like it gives you exactly the same number of stars, which are 20, right? Another alternative you can do is you can start from the largest to the smallest. So as you can imagine, like the example that we have here is a kind of like a naive example, but we would rather we are more interested in how to write things. For example, the last one that is writing for them the largest to the smallest, we use this one in our example of uh, inversing the integers that are inputted by a user. If you remember this example, so we ask the user to input 20 integers one by one, and then we are asked to bring them in a reverse order. To be able to do this in a reverse order, you have to start from the last one, right? And here comes this format of the for loop, which is starting from the maximum and keep decreasing of your iteration. So you go 20, 19, 18, etc., until you stop at 1, right? One of the things that I see people get tricked with in exams or tricked by in exams is you need to differentiate whether you are starting from 0 or 1, and this will, in some cases, these kind of tricks are played to do to do completely different things. If you start from 0, which is this one, and then you have less than, you need to take into account your start point, which is 0. And if you start from 1, you need to take that into account, right? And both are not equivalent. In this example, they are very easy because we just are interested in 20 counts of stars. But if you are accessing, for example, a memory element like an array, if you start from 1, you are skipping your first element in the array, because arrays in C starts from 0. This is one example of why you need to really pay attention to what you write in a for loop, and they are not equivalent in most cases. Good? Okay. So here, another alternative that you can play with is, as we said in I guess the very first slide of for loops, is generally this third statement is your expression for doing some math operations. So this is an arithmetic expression, right? This arithmetic expression does not necessarily mean it has to be either incrementing by 1 or decrementing by 1. In fact, you can write anything. As you can imagine, I can even multiply, right? It's the general rule is that this is an arithmetic expression. So you can build in more convoluted or more involved examples by taking into account the general rule. Here, we're doing a simple thing, which is just doing a step of 2. So instead of incrementing by 1 each time, you take a step of 2. So you start from 0, and then 2, 4, 6, 8, right? So you can do whatever you would like to do. Good. So again, taking this into the general format of a for loop, you have your initialization. This is the first expression here, which is the first step of any for loop. Then you have the condition to check, which is the second one. So let's call this is the first one. This is the second one. And finally, after doing the body of the loop, which is the actual statements, this is the body of your for loop, the things that you want to execute in multiple iterations. Finally, you kind of play around with your increment expression, or generally it's not necessarily increment, with your advancing condition, whether this is advancing in decreasing order, increasing order, adding, subtracting, doesn't really matter. And this is the third element of a for loop. Good. Great. And then in the same lecture we covered for loops. We also said there is a completely equivalent type of loop, and I know that this is also a revision from Python. So but I wanted to touch on the general rules to make sure we are all on the same page. So whatever you can write in for loop, you can do exactly the same functionality in a while loop, and even do while. And this is what we said in our example lecture, right? So generally, how you can model a while loop in a flow chart: you have a condition to check first, and then you execute the statements through the iterations, and then you go back to check your condition, right? So if I want to write the equivalent while loop of this for loop, I want, first of all, because while itself does not include any initialization, that means you should have your initialization before the while loop. And then you do the while loop, you take the second part, which is a condition. And then finally, the increment, also while loop itself does not have any increment, so you need to include the increment at the end, right? So these are the 3 steps of your for loop, right? The first one is initialization, second one is condition, third one is your advancing expression, right? Good. So this is the general rule. That's okay. We already discussed that. So let's go to do while, right? For do while, we said the main difference between do while and while is in do while um, you execute your body, your statements once before you check the condition, which means at least in while loop, it's possible that you skip the whole loop if your condition from the beginning is not correct. But in do while, you execute it once. And we have shown in the example why you might need to do this. For example, if you're taking an input from the user, you need to take at least one input to check your condition, correct? So here, as you can see, we have that we brought the statements and why the statements were here. So we brought them before the condition, which means I execute it once and then go to the condition, right? Putting this kind of flow chart in your mind is important, because I know that the examples and lectures seem pretty easy, but in fact, if you don't grasp these flow charts of different loops, all kind of tricks can be played. And this is usually a kind of trick that people like to play in an exam or in an simple question in an interview, is to make sure you get these things. Good. So here, if I want to do this example using do while, what I would do is initialization. That's the same because it's outside the loop body anyway. And then instead of having the condition before the start, you have it at the end, right? Now the main question is, are these two equivalent, right? And are they equivalent under all scenarios, right? Because you need to think about them, right? In most cases, they can be equivalent, right? But for example, if I assume that I have let's say n is equal to 3, and now I initialized I to 1. So let's say n is equal to 0, right? In this case, what's going to happen? Let's see. In the left side, which is a while loop, is I is less than or equal to n? No. So you never execute that, right? So nothing is getting printed. What about the right-hand side, do while? Because I don't check the condition until the end, I'm going to print. So I'm going to say here, I'm going to print I, which is 1, and then increment I, and then check. I find that, in fact, I is not less than or equal to n, because n is 0. Then I don't go ahead and execute. So here, nothing getting printed. Here you print 1, right? So there are cases, to put the rule in a general way, the cases where do while is different than while is the case where the condition is not met, right? So if your condition is not satisfied, do while will get executed once, while will not get executed at all. But other than this, both are equivalent. Good. Okay, let me stop here and take questions about loops. Can we please follow our convention? If you have a question, put a question between brackets to make sure I can quickly spot that. Can we explain what is I less than mean again? Is that where increment variable ends? I less than 10 is your condition. Matthew, this is your question. So you have a condition to exit your loop, right? Because you want to exit a loop is simply a part of the code, number of lines, statements that you want to execute multiple times, right? Based on a certain condition. I less than 10 is the condition that you exit the loop in. So if I is larger than 10, for example, you exit your loop. Okay, I don't see any other question. Where n is equal to the do while would run once, but the while wouldn't. Yes, Moaz. That's the main difference. Is in the example we gave, if n is equal to 0, because I is initialized to 1, that means I is not less than or equal to n. So your condition is false, which means while will not get executed at all. You will never enter the while body, but the condition is checked later, which means you execute it at least once. Would be preferred to write I less than or equal to 10 compared to I less than 11? This depends, Abigail, that's a good question, but this depends on the use case, right? Sometimes it comes naturally to what you want to do. For example, if you know that you have a number of students equal to 100, right? It's natural to say, I'm going to check until I is, for example, less than or equal to 100. You will not say less than 101, right? So it's dependent on the use case. They can be equivalent mathematically, but put readability into account, right? So it depends on what you are writing. So there is no general rule here. Nothing is preferred under all conditions. It depends on what you are doing. Good? Okay, so previously you had multiple types about data, multiple questions about data types, and I didn't want to add this by then. So let's look into generally what are types in C, right? We have characters, and this is the basic, this is the minimum size type in C. It's a single byte, right? So a character is a single byte in C. And then we have int, which is integer, and this is generally either 16 or 32 bits. As I said before, it depends on your hardware. In most current hardware is 32. I doubt that maybe any of you has a machine that has a 16-bit integer. That would be a very old one, right? But to be precise, it's either 16 or 32 based on your hardware. And then we have different variations of int. We have a short int, and this short int is 16-bit. We have long int, which is, as we will see now, it's at least 32 bits. It can be more, in fact. Then we have, this is for the integer values. And then we have float double and long double for the decimal or floating point variables. And we said before that float is less than double. Double is double precision, and float is single precision. Float is 32-bit and double is 64. Or in some machines, float is 16 and double is 32. I wouldn't bother too much, or I don't want to confuse you about the actual size of each type, but you just have a sense of which one is larger, which one is small, right? And then in addition to these types, you can in fact add some other kind of specifiers, right? So you can say, I have an int, but it's not just an int, it's a signed int. So now you specify that your variable is in fact signed value. So it will not, it can have positive and negative, right? Unsigned, you are kind of determining that your variable should be only unsigned. It cannot have a signed value, right? And the signed, unsigned apply to character int. We will see now why it applies to character, which may seem counterintuitive. Character is just a character, is like a single character, right, of your keyboard, C, A, B. How it can be signed or unsigned. We'll come into this now. But it also applies intuitively to int, short, long, because these contain like some values, right? Good.
I think we went over this last class.
Did we? I thought we stopped at the for loop. Oh, really?
I don't think we did, but I could be wrong.
Yeah, I don't think we did either, but
yeah, maybe I mentioned some of these in some lectures, but okay, let me quickly go through this. At least the important information that I want you to know, and then if there are further questions, I can take later. Good. So this is what we mentioned, is that short and long are specific types of int. The shortest should be at least 16-bit, but because it's short int, so its maximum size is the int, while long short is at least 32 bits, and it cannot be smaller than a general int. Okay, what is important here to understand? And this is something that I want you to understand because it also applies to digital design, it applies to embedded systems, it applies to understanding of how the hardware really works, right? What is the differentiation between a signed and unsigned type, right? Assume we're talking about ints for now, and assume that we have a 32-bit int, right? So our integers are getting stored in the memory in the 32-bit storage, right? If this is an int, if we are talking about a general signed int, which means it can take any value, whether it's positive or negative, what are the possible values of having an int that has 32 bits? If you have 32 bits, that means you can write anything that is in the range of 32 to the power 32 minus 1, right? Because you have 32 bits. It starts from 0 and up to the power 32 minus 1 if everything is 1, right? And maybe you touch a little bit on this in digital design. If you have 2 bits, what are the possible values you get? It's either 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, right? So you have 4 values, which are in fact 2 to the power 2 bits. And the maximum value it takes is 3. So it's 0, 1, 2, 3. So you can generalize this by saying the range of the values of any 2-bit is in fact 2 to the power 2 minus 1, from 0 to the power 2 minus 1. But here we are talking about only unsigned values, right? Because we said 0, 1, 2, 3, correct? So if you generalize this, instead of 2 bits, you can have any general of b bits. So an unsigned variable of b width, it would take from 0 to 2 to the power b minus 1, right? If we are talking about 32 bits, so you range from 0 to the power 32 minus 1, right? But this is only if it's unsigned, because it only has positive or 0 values, right? What if it's signed? And that's what is important to understand. If it's signed, you need to specify your last bit to be your sign, correct? Which means here, if we take the 2-bit example, in fact, you can either has a 0 or 1, right? Which means, given that's positive and negative, so you range from -1 to +1. Right? So it's like you divided your range into negative and positive, which means you have half the values. So you would say for the sign case, you have positive or negative 2 to the power. Instead of 32, it would be 31 minus 1, right? So this would be the, because you took 1 bit out of the 32 to express your sign, and then the remaining ones would be your I don't want someone to get this confused to be 0, it's 31, right? But this is the main difference between the signed and the unsigned, right? In the unsigned case, you start from 0, so you take your full width. If you start from signed, you have half of the values are negative, half of them are positive by taking the last bit to be the sign. So this is the expression of the sign, and the remaining ones would be used for the actual value, right? Why I'm kind of spending too much time on this, why it has less relevant to programming, because first of all, it's important to understand the hardware, and it's important for the software development. Is, for example, assume I know that I'm talking about a specific number of students, which means they will never be a negative number of students in any class, right? Given that I know the unsigned int can represent more numbers, right? So it's in your favor to write your code in an optimized way by defining your variable that expresses the students as unsigned int. Because in this case, you can model double the values of the regular int case, right? So now, as if you doubled your memory for free, because you know your use case, right? So that's very important in software development, right? Especially if you are doing this in embedded device or mobile programming or wearable programming, something that has a memory and a storage limitation. Good. Let me see if there is any question related to this. That's a very important point. What's the difference between single precision and double precision? We will come into this now. Okay. Is there another question here? What would be preferred try? This is already addressed. Good. Okay. Okay, here are some of the ranges. So remember I said you have this is to the power 16, it's 15, to the power 15 minus 1. If you try it in your calculator, you'll find it's to the power 15 minus 1, right? Because you took 1 bit for the sign, and then you range from negative to positive. And then int. So as I said before, also an important thing is by default, if you didn't specify, it would be signed, right? So if you just write int, that means it can take both negative and positive values, right? But if you say unsigned, as you can see, you start only from 0 and you go up to here. You can already see this from here. The maximum value represented here is double the value that you can represent using exactly the same number of bits for the case of unsigned compared to signed, right? Good. Do you need to memorize this? No at all, right? You just need to understand the intuition behind it, right? Good. So the question was, what is the difference between double precision and single precision? This is an expression in computer arithmetic where this depends on, it's an IEEE standard for floating point representation. And I guess the more you go into digital design, you will get this as well. But the main thing you need to understand now is single precision is less representative or less accurate or has less number of bits to store the value than the double precision. Generally, double precision is 64-bit, so it's either represented using 232-bit registers or a single 64-bit register in a modern machine, while single precision is only in 32 bits. Good. So as you can see here, float is it's kind of like it's like a smaller type or less precise, this was single precision versus double precision, less precise type compared to double. Good. Great. So many things we said it's implementation dependent, right? How do we know the limitations of our machine? Assume I want to write something that I know it's going to have like huge number of, for example, students or a population in a country. So I would have millions and millions of users or millions of records that I want to operate on. And I want to know exactly the limits of my machine. So how to get this? In the C standard library, there is a header file called limits.h, and it has constants that kind of fetches these numbers from the machine for you. For example, we have this int underscore max. So if you include limits.h, and then int underscore max will tell you what is the maximum value you can represent using an int in your machine, right? Short underscore min would be the minimum value you can represent in your machine. Int underscore min, what is the minimum value as well, right? So underscore min underscore max tells you what is the maximum and the minimum in your machine. Good. And this is with regard to the integer values. With regard to the floating point values, then you also have something similar in the float.h. So it tells you what is the maximum value for a double or a float. Good. So for example, if you write something like I want to printf the maximum value of a short in my machine, and then you use short underscore max, and short underscore max is already defined in the limits.h, it will tell you, for example, this is the maximum value, for example, right? So you can try this in your own. It's very simple to just waste time to try it together, right? But it basically tells you if you know that your program, here is like the main lesson. If you know that your program is going to somehow stress the limits of your machine, it's better to use these predefined variables to know first what are the limits of your machine, right? I'll give you one example to clarify. Assume, for example, you are reading inputs from a user, right? And this is a very simple application of that. And you know it's an int, so you're going to place this value in an int. But as a user, you have no control on me. I can write anything, right? Even numbers that can exclude or exceed the values of an int, right? So how to guard your program against this? And instead of just taking, remember we wrote this program, scanf, reading something in an int, and then there is a variable that I don't know, we call it num, right? And instead of doing this, you can say, I'm going to check. First of all, I can also give a kind of a helper message to the user. Say, enter a number between, which is your int min and int max. And then you give me a hint as a user to know that I cannot exceed that. And then do an if condition to check if the value I entered is exceeding this. And if it exceeds this, you give me a warning saying, oh, you already exceeded the maximum value. So you can guard your program against either unintentional or intentional bad user behavior. Good, using these limits. Okay. So now, okay, we talked about types in general, right? What are their limits, what each one of them means, and how to interpret each of them, right? What if I want to write constants, not defined variables? So it's not, I don't want to say something like int x. I want to write a variable like say, okay, int y equal to something. So for example, 3, right? So write some constant values or immediate values. Sometimes we call them immediate values of a certain type, right? So if you're talking about int, this is the thing that we are all familiar with. So you can just simply write the number you want to write as 0, as positive value, as negative value, as far as it's int, right? But assume I define something to be, I entered the value, but I want it to be stored in a long, and I want it to be represented as a long int, not just an int. So you can write the number, and then at the end, put the suffix L or L. By doing this, you are telling me, for example, I can write something like long int equal this 3988L, which means represent this number to me as a long, and then place it in the int, right? So for the same thing, if you want to write something to be signed or unsigned, right? If you want it to be unsigned, by default it's signed because this is what we said before. If you want it to be unsigned, you can just write U either capital or small letter at the end of the number, right? In fact, something you don't know, but maybe I don't want to touch in details now, is even you can write your end as a hexadecimal. Did you guys cover hexadecimal representation in digital design or not yet? So you can write ints as like 0xFF. Do you know this representation? So you can write, it's like binary format. Maybe you are familiar with the binary, right? So if I'm talking about, for example, 3, I can write 3 as 1100, correct? This is a binary representation of my decimal floating point. So, and hexadecimal representation or binary representation is a form of writing an immediate value, and this is allowed in C. So if you try it, it will in fact work, right? Sometimes if you are kind of modeling something that is related to digital design, you won't write your numbers like this, right? Okay, good. So this is about int. What about double? I can write my double, and again, this is the normal thing that we usually write, but something you don't know is also you can write your decimal immediate value or decimal constant in C in this exponent format, like it's called Mantes-and exponent representation. For example, I can say double, and the same thing for float, by the way, right? So I can say double equal 4.6 E, something like this, right? Which at the end means this value would be 4.6 multiplied by the 10 to the power -9, right? So this is a possible representation of a constant in C. So you don't necessarily need to write this, especially this works for very small numbers. If you want to write this in your regular format, you would write 0.00000, like 9 zeros and then 4.6, right? That's not an efficient way of writing numbers. So also C is rich in allowing you to write this format, right? Good.
I have a quick question.
Go ahead.
When you say constants, do you mean these are constants assigned to a variable, or these are just numbers that we're writing in an equation or something?
Okay, that's a good question, Arjun. So it's both, right? So you can I mean by these immediate values. Immediate values can be used in two different ways. Assigning them to a variable similar to what you said, for example, double y equal this, or use them in an expression. For example, I can say, okay, double y equal this multiplied by 10 divided by something, right? Or another way of expression is a comparison expression. For example, if y is less than or equal 4.6 e to the power -9, right? So any use of an immediate value, this is what I mean by this.
Okay, so that's why it's useful being able to assign like unsigned long or like long or
exactly
whatever, so that we can make sure we don't run into issues between like
different types
type
comparisons,
conversion.
for example.
Yeah.
Correct.
Okay.
That's correct. Thanks, Sanj. Okay, let me see. There are other few questions here. What is E after the decimal point? Okay, so this E is a way of writing a decimal representation in a format that is common in computer arithmetic. It's called exponent. And just the translation of this is 10 to the power, right? For example, 3E -7 is 3 multiplied by 10 to the power -7, right? And the same thing whether it's E capital or small, right? So you can just remove this and write this as multiplied by 10 to the power 2, right? This is how we read it. Good. There was another question, I guess. The suffix character would be C. Can we define float? Not sure if what you mean by suffix character is C. For character, we will come into characters for now. We didn't discuss characters. Good. Okay, so characters, good. We said characters are the simplest type because they are single byte. Something that is, in fact, different between C and many other languages is character. Okay, you can define something as a character, but in fact, the machine itself, the compiler, the C toolchain deals with characters as if they are completely integers, right? And this is something like maybe differentiates C from other languages. For example, I can do something like A plus C. In some languages, this plus can mean concatenation, and you would expect AC as a result. On the other hand, C is doing something different. C sees characters as an integer, so it will replace A with its integer representation, and we will see now what does that mean. For example, A would have 38, for example, and then C might have, I don't know, like 41, and then you add these two together, and then they give you an integer value, right? Because characters generally, they are represented in our machines at the end as integers, in fact, right? And this is, again, something that is very specific to C and some other languages that are based on C that is important to understand, right? So you can do arithmetic operations in characters, not because you can concatenate strings, but because they are inherently integers, right? And because it's a single byte, so it's 8 bits, so you can represent, depending on whether they are signed or unsigned, you can range from this to this, right? Good. So when we said characters can be represented as integers in our machine, what did we mean by this, right? When you hit a character in your keyboard, for example, A, H, or 5, or percentage, anything, right? How your machine is knowing that you hit this character and it means H? In fact, there is a standard representation of each keyboard character. It's defined as, if this is A, then it has the following integer value. For example, 38, as I said. And then the machine deals with this binary representation and takes it, stores it, and does something, right? So we have a table that we call ASCII table. Some of you may have heard about this before, some may not. But looking into, forget about what these things for now, but we'll come into this. But this is the ASCII table, right? What we mean by ASCII table is, this is the table that is the standard format that tells you for each character in your keyboard, and it's like an English or Latin based keyboard, it has a certain representation. For example, if we take F here, that means F is represented as 70, which is 70, right? So the integer value of F is 70. How to check these values, right? Assume that you want to check it in your machine. Something you can do is, if you print your, assume that this is an S character, right? S, small s. And the specifier, remember we said specifiers before, the specifier of a character is %C. If you print this as character, it will give you small s. But if you print it as D, which is an integer, it will give you the integer representation of S, which if we look here, we'll find that small s somewhere here is, let me see, here, it's 11 and 5 in hex format. If you do the math, it will give you an integer value, right? So if you try both, and then I encourage you to try this when you study this lecture, is try to present some character as, to print it as a character and also print it as an integer and look into the difference, right? So, okay, we said this is the standard format. The ASCII representation is the standard one. That's correct. But recently, especially because the Latin-based languages have a limited alphabet, for example, only 26 letters, etc., etc. So some other languages like Mandarin, for example, or Arabic or Urdu or whatever, they may need more values than, we said characters are 8-bit, right? So which means you have a maximum of how many characters? You said 128 or 127, right? So that means if your language has more characters than 127, the ASCII will not be able to represent it. So there are other standards that are becoming more and more popular, and one of them is the, and you'll find this in your text editors, for example, the Unicode representation, right? So it's a wider bit. Sometimes it's 16-bit or 32-bit, which means you give more freedom to represent more characters, right? And in some newer C standards, you are able to present your character as something that is in 16-bit or 32-bit using that, right? Character 16_T type or character 32. Good. Okay, so how to know what are the limits of my machine? Again, character is an int inherently, so you can use the limits.h file, and it gives you two variables, character min and character max, right? This tell you what is the maximum and the minimum value that your character can have. Good. Okay, let me see questions. We don't need to add the and symbol before s. Oh, printf region, like we do this and thing for scanf, because scanf is changing the variable you are passing, right? But printf is just printing whatever you give it, so you don't need passing by reference there, right? The dot makes it float. Yeah, so if for 0.1 or 1.0 makes an immediate value a float or a decimal representation. That's correct. Can you give an example of using suffix u? We said u means, sorry, unsigned, right? So assume, for example, as I said, the example I give students, for example, number of students, I would say int student underscore ID, but I want this to be unsigned. So I can say it has, I don't know, like 3 and then u, right? Which means please present, I'm telling the compiler, please present 3 to me as unsigned value and assign it to the student underscore ID variable, right? It's an example of using unsigned. If the ASCII numbers are all positive numbers, what characters will be represented by negative number character? That's a good question, right? So this is why it's machine dependent, right? So it depends on, so okay, so that's a good question if you're talking the English alphabet, but, and this is specific to this machine. In fact, I suspect that some of your machines would only have the unsigned character, which means it's 0 to the power 128. I guess, Ning, your question here is referring to when we tried the min character and max character limits, right? It was negative 127 to, I guess, 127 or something like that. According to the ASCII, nothing is represented as a negative value, right? So the ASCII representation, it doesn't have negative value. So nothing is going to be presented as an ASCII. But for example, if you are using a different coding like Unicode, you are allowed to do that, right? If you are trying to represent a different language, also you might have some name. So ASCII, we have to differentiate between the ASCII standard and the character type in C, right? Character type in C is just a placeholder or a type for 8-bit number that can either be signed or unsigned based on the implementation of the machine. It's best suited for the ASCII representation, but it's not completely equivalent. Good. Okay, so another thing is how to write. So for every type, we discussed how to write immediate values or constants of int, double, float. What about characters, right? For characters, you need in C to have a character, to have this as in between single quotes, and it has to be a single character. For example, X, A, 3, 2, 1, right? But they have to be between these single quotes. And some other types of characters are also the special ones that some of them we have used before as new line, right? These are already things that are known, and this is part of your keyboard. You want to hit, sorry. You want to hit a tab or a new line or a vertical tab or backslash or backspace. All of this would require this escape sequence representation, and they are considered as also single characters in C. Good. So one thing that is important to understand, as I said, is the integer representation of your immediate value. For example, capital A is 65. What if we want to try to add something like this, right? We said inherently these are ints, which means you can add them and you can take the value into an integer value, right? So what would happen if you try it in your machine is you'll find A has the value of 65, A small has the value of 97. You add them, gives you 162. So if you try to print X, this gives you 162, right? On the other hand, if you tried something like this, X equal A plus A. Can someone imagine what you might expect? What would happen if you try to print X in this case? Error, no, not AA, not 162. A new character, that's correct, but depends on what character, right? Sum of ASCII value. Okay, so what would happen in the compiler is, first of all, given that this is an add operation and these are ints, you would add 65 plus 97, it gives you 162. Because you take this into a character, you go to the ASCII, the hardware will go to the ASCII table, see what is the representation of 162, and it gives you the character that has this value, right? Good. So try these two in your machine, like while you try to study the lecture, and look into the different values. One last thing we want to discuss before the end of the lecture is okay. Let me just is type conversions. We have been talking about I want to add two values or assign some expression. What are the limits of my different types? But it might be a case, and in fact we tried this in one of the examples by passing, for example, a float into an int function, right? What if the expression evaluates to a type that is different than the type of the variable you are putting in? For example, I have something like int x equal 2.5. What would happen, right? So this is called generally like type conversion. And in type conversion, sometimes the compiler will do it for you by default. Sometimes the compiler will complain if the conversion is not possible. And we need to understand this like very clearly, right? Usually, if you have an expression that have different terms, some of them are narrower than narrower types. Narrower types means they are smaller in size. And some of them are wider types. The whole expression would be evaluated according to the wider type. What do we mean by this? For example, if you have an expression that adds a float representation number, like something like 2.5 into 2, it makes sense. It's intuitive that the whole result would be a float, right? So this is of type float, this is of type int, and the ending result is of type float. This is what we mean by converging the, doing the conversion for the whole expression for the wider type. So we need to understand what are the wider types. Here we show the types from the left to the right, from the narrower to the wider. So int and long, then long is wider, float is wider, double is wider, long double is wider, right? So for example, if I define something like int x equal 2, float, oh, I already gave the example of float. So let me do something like double y equal 3.5. Then I do something like, and this is going to be tricky now, right? nz, and then I would say here z equal x plus y. And these kind of tricks are also played, like in exams and interviews and in programs. If I asked you, what is the type of this expression? You might say, oh, the end, it will be an int. That means it's an int. That's not correct, right? You need to understand how the expression will evaluate. So here, I'm adding an int with a double. And according to this rule we have just discussed right now, int plus double, the whole expression should evaluate to double, which is the wider, right? And then after evaluating this, for example, 2 plus 3.5, this gives you 5.5. After evaluating the expression to the 5.5, you want to put the value in z. So another conversion happens from double to int. Does this make sense? Okay. So let's look into the examples we have in the slides here. For example, if I'm dividing 12 by 5, what you expect the value and the type of this expression. First of all, let's look about the type. It's an int divided by float or double. So the type is float or double. What about the value? It would give you something like 2, I don't know, like 2.25, is it the case, or less, right? So it would also evaluate to float, right? What about something like this, right? And that's again tricky. This is an int divided by int. Remember last time we discussed operations and we said if you divide int by int, the whole expression is int. So 1/2, this should evaluate to what? Can someone imagine what would be the final result? Let me see here. Yes, 1/2 is 0, and then it will add up 0 plus 10.0. So the value is 10.0, and the type is float or double, right? Good. Good. Every expression has a value on them. This is what we already discussed. And the value of the assignment is what is in the expression, and the type of the whole thing is at the end, the type of the variable you assign to. We have already covered this. Good. Okay. Type conversions we have discussed. Another example here is that int x, like k will give you a 2 because at the end k is int, so it truncates, right? Something like this. What about this? That's also tricky. So I have an expression that have multiple assignment operands, right? So you should start for your assignment from the right. So what would happen is first x will get the value of 2.45, correct? And because x is double, so x would hold 2.45, right? And then x would get assigned to j, but j is an int, so j should have the value of only 2, correct? So the assignment would happening from the right to the left, and that's very important to understand. And according to the type of your destination, the value would be different. Good. What if we invert? What if we reverse them? Now it would be different because j is an int, so j will be 2, and then j will be assigned to x, so x will also be 2. Correct? So you see that the order also makes a difference, right? Because you start the assignment from right to left. Good. So what if I want, okay, this is what happens by default in the compiler, right? But what if, and this is what we conclude with, I know that maybe time is already over, but this is what we conclude with is this, the compiler does for you automatically by default. You don't need to bother, but you need to understand. But what if you want to write your program in a certain way to enforce a certain type conversion, right? In this case, we call this casting, right? So let's see what happens. Assume, for example, I want, so, okay, let's look into these two expressions to understand how things happen, right? By default, what would happen for 17/4? It's an n divided by n, so it would give you 4, right? Because it will only give you the correct integer value of it's supposed to be 4.25, but you truncate it, so it gives you 4, correct? What if I want the result to, in fact, to be the actual value, which is 4.25, right? In this case, I do what I call casting. Casting in C happens, you open parentheses or brackets, and then you write the type you want to cast to. For example, if I want to cast to float, there is a difference between these two. For the first one, I'm only casting what is next to me, and this is an important rule in casting in C. That means I'm casting 17, right? So if you cast 17, the compiler will see 17 as float, so 17.0. And then you divide by 4. So now it comes as if you divide float by int. So it should give you the 4.25 because float by int, you take the wider, which is float. On the other hand, by doing this, remember, according to the precedence constraints, you do the division first. So it gives you 4. And then you cast the result. So this will give you 4.0, right? Good. So you can do casting, but you need to understand what are you casting to? Are you casting a single operand? Or are you casting the whole expression after evaluation? And both are not the same, right? Okay. Something also in C that is different than Python, for example, is that in C, there is no inherent Boolean type by default. We don't have Boolean. We don't have false or true. On the other hand, we represent Booleans as integers, right? Which means your conditional checking or your what we call relational operators, they evaluate to int. And this int is either 0, which means it's false, or any positive value, which means, or negative value, which means it's true, right? For example, if I do something like this might not be valid in Python, for example, but it's valid in C. Why? Because this expression is evaluating to int. Is 100 not equal to 200? Yes, that's true. But true in C evaluates to 1. And now you are adding 1 plus 100, so it gives you 101. So this might be counterintuitive, how this thing gives you 101. But this is how C operates. So to understand this, or the intuition behind this is, these relational operators evaluate to either 1 or 0 based on whether they are true or false. If they are true, they evaluate to 1. And 1 is an int value, right? Good. Is there, let me see how much we have left because, okay. No way to finish today, and I don't want to keep you like for more than this. So let's finish these slides at the beginning of coming lecture. But so we are done for those who have other lectures to go to or want to leave. But I will just remain for a few minutes to take the questions. Okay. Thanks everyone, and see you on Wednesday.
Professor?
Yeah.
I have a quick question about the labs. So, for example, the last question was the question 7. There's
Okay.
2 parts, right? The first part only
Correct.
asks you to do the 7 digits, and the second part is to do the generalized case. The thing is, I code the second part first, and now for the first part, do I have to do it specifically for 7 characters, or
Yeah,
can I
that's
just
an
modify
excellent
it?
question. So no, you don't have to. But as I said in last lecture, you are encouraged to think of how to leverage this limitation in the user input to see how you write your program differently, right?
Okay.
So it will not affect your grade at the end for the lab, because the general solution would still apply to the special case.
Right.
But the main purpose of the question is to show you how leveraging a special case can give you a different solution.
Okay.
Right.
All right. So just to be clear that I can just implement the
same one for both. That's
the same one for both. Okay. All right. Thank you so much.
Yeah,
all right. Have a
you're
good day.
welcome. Thank you. You too. Okay, question. For question 1 in the lab, we need numbers between 30 and does that include, I don't remember this specific one, but if I recall, yes, it includes it. Is there any one midterm for this course? Yeah, it's a single midterm. That's correct. We'll only give a check mark once the entire code is working. That's correct. It will give you only this green check mark once the entire code is working. But if you are working in a question by question basis, you can go like you can click your, now it will be a red X mark. And if you go inside, it gives you a detailed report that you see from Eclipse as well, which is what questions failed and which passed. For example, if I'm writing only question 1 or question 2, it's just okay for me to pass these for now. So I'll check question 2 test cases. If they pass, great. Others, I wouldn't care for now, even if you get X red mark, because you will continue tomorrow and after tomorrow, right? So also take it as in a gradual or agile way. Logical operators return ends and not Boolean. False equals 0. That's correct. For the lab, in question 1 and 5 specifically, how do we test? No. Okay, as I said at the beginning of the lecture, question 1 and 5 don't take inputs. So you don't, in fact, you don't need to. You can write test cases, but it will be exactly the same as the one we implement. So it will be redundant, so you don't need. I know that you are asked to write at least a single test case for each question, but in question 1 and 5, or generally any question that takes no input, that's just a redundant effort. So if you don't want to do, that's okay. Do we need to write comments for the code? You are highly recommended to do so, right? Because this will facilitate the marking as well after going through the automation process. So what we do is we run the test cases we give you. We run the test cases we have internally that we didn't give you. And then we look into the code if there are problems happening. And then your comments would at least help us see how you think, right? So in case that, for example, you didn't pass, or there is a problem that happens that makes you not passing one of our test cases, we see if you understand things, right? I have only writing code for question 1, but somehow in passing tests or other questions, is that normal? No, Katie, that shouldn't happen. I don't know how, but maybe you can come to office hours and we can check. So we don't need test cases for 1.5. Yes. Logic operators always return int, yes, Moaz. The green check mark doesn't show up after get push. Is that normal? You will either have, if you look into the GitHub, you will either has this green one or the red one. But maybe it takes some time, right? You need to add a test case for every question in the test case. Do you see? Yeah, Ian, I already answered this by saying yes, you need, but maybe for question 1 and 5, you don't need because they take no input, right? Do we need to? Okay, let me see if there are other questions that I've bypassed. Nicole, 50 plus this results to what? Okay, 100 not equal to 200. This expression evaluates to true. In C, true is 1, so this evaluates to 1. 50 plus 1 gives you 51. Okay. For question 1 in the lab, we need numbers between, okay, I already Okay, let me see if there are other questions. Are your office hours through the same link as the one for the TA? No, Katie. Like my office hours are in a different link that I also broadcasted to everyone. But my office hours are only on Tuesdays. So the link for the general TA office hours is for the everyday office hours, and I usually also drop there from time to time. Okay, if there is no more questions, I would just say bye for now, and then see you in office hours. Maybe I just be late for 5 minutes, and then I will start the office hours. Can we explain again how we can represent larger numbers when we can only do 128 with ASCII? Is that, yeah, so the two slides for, you will not be basically using the ASCII representation. In C, we have this character 16 and character 32, which usually use the Unicode encoding, not the ASCII encoding. Good. Thanks, everyone, and see you later. Bye-bye.